Okay, good morning class. So some reason or other it cut the video cut out. So we're busy with functions. At this point we have dealt with given the equation of the function and we had to draw the graph and interpretation thereof. So today we're going to look at determining the equation of a function. Okay, and we're going to look namely at determining the equation of a quadratic function, a parabola. Okay. Okay, now there's two. So there's actually three, but some reason or other they cut out the other one. So you guys have two scenarios. Okay, one being where you are given two x-intercepts. You have to determine the equation of the graph. Or we have a turning point and another point on the graph. Okay, so we're going to start off with given the x-intercepts and the coordinates of one other point. Okay, then this is what you guys have written down thus far, no? And this is on page 158. Here's examples. One on page 158. Okay. So we are saying determining the equation of the parabola given the x-intercepts and the coordinate of one other point. If the x-intercepts are given, we start with the equation of the parabola in the form y is equal to a into x minus x1 into x minus x2, where x1 and x2 are x-intercepts. Okay. So if you are given x-intercepts, you must know this formula. You must write down this formula. Y is equal to a into x minus x1, x minus x2. So you write that formula down and you make a note there. If given the x-intercepts and another point on the graph, you write this formula down. Okay. Now this formula is not given in the exam, so you must remember it. Okay. So do I have the two x-intercepts of this graph? Yes. I have negative 2 and I have 6. Not so? So what do I do is I substitute that in there. So my equation now reads y is equal to a into x minus minus 2, which becomes plus 2. And x minus 6. So have I answered the question? No. Why? Because I still must solve for a. Not so. So do I have another point on this graph? Yes, I do. I have 0 and 2. Otherwise I could have gone with that turning point there, or I could have read that point off there, or many other points I could have read off this graph. Okay? But I'm going to take, in this case, I'm going to take 0 and negative 12. So at this point, you're going to substitute 0 and negative 2. So do the substitution into the formula, and then you solve for a. Alright?
So may I come in?
Yes, you may.
Can I do purpose, please?
So you owe me 6 today? No, you owe me 26 today. Alright, take it.
Sorry, I remember yesterday.
Let me give you a 74. Okay. That's the x and a y. So I have negative 12 is equal to a into 0 plus 2, 0 minus 6.
I'm going to come right now.
So, okay. So 2 times negative 6 is negative 12a. Negative 12 divided by negative 12 both sides. So a works out to be 1. So y is equal to 1 into x plus 2 into x minus 6. From here we just multiply out. I get x squared minus 4x minus 2. Okay, are you all okay with this? Any confusion? Right. So what I'm going to do is I'm going to give you 2 sums to do from the exercise in the textbook before we do the equation of the other one. Okay. Okay, there's the first one. It's out of exercise 5.18, number 1. A, page. What page is this one? 160. Okay. Okay, so do that for me quickly. Pause the video at this point. Okay. So remember what is the formula that we give you? That we're going to write down? What's the formula? Y equals A into x minus x1, x minus x2. Okay, where x1 and x2 are the x-intercepts. So we have y is equal to A into x minus minus 1, which is plus 1, and x minus. So what do I do now? Substitute the point that's lying on the floor. So we substitute 0 and negative 8. Remember, that's a x and a y. Also, so we have negative 8 is equal to A into 0 plus 1, 0 minus 4. Okay? 0 plus 1 is 1, 0 minus 4 is negative 4. 1 times negative 4 times negative 8 is, times A is negative 4. Divided by 2, divided by negative 4, A is equal to 2. My equation now reads y is equal to 2 into x plus 1, x minus 4. But normally they want it in the form of y equals ax squared plus bx plus c. They ask you to write it in that form. So what do we have to do? Multiply the story out. So we have 2x squared, that's going to be negative 3, so it's negative 6x minus 8. You all okay with that? Any confusion? No? This is C of the same exercise, number 1C, on page 160 out of exercise 5.18. Okay, so do that for me quickly. We'll again pause the video at this point. Okay, again, what is the formula that gets written down? Y is equal to A into x minus x1, x minus x2. So they do x-intercepts minus 6 and minus 2, so y is equal to A into x plus 6, x plus 2. So we'll substitute the point that lies on this graph, which is negative 1 and negative 10. Remembering, that's a x and a y. So we have negative 10 is equal to a into negative 1 plus 6, negative 1 plus 2. Which then gives you 5 and 1, which is 5a equals negative 10. Divided by 5, so a is equal to negative 2. Which explains the graph being a maximum graph. Can you see that? A value is negative. So we have y is equal to negative 2 into x plus 6, x plus 2. Get rid of the bracket, so y is equal to negative 2x squared. It's going to be 8x minus 16x minus 12, so it's minus 20. Can't be positive. Sorry? Sorry? Did I make a mistake? Okay. This point is actually here somewhere. Can you see that the x is negative? Huh? Is you the problem. Okay. Right, you guys understand? Now let's look at the other one. Given the turning point and the coordinates of one other point. This is example on page 159. Example on page 159. Here we are given the turning point and the coordinates of one other point. If the coordinates of the turning point are given, we start with the equation of the parabola in the form y is equal to a into x plus p all squared plus q, where negative p and q are the x and y coordinates of the turning point respectively, which means to say in that order. Okay, at this point you have written this down. So, looking at this here, we're going to use that formula. I know they use the positive p, we use a into x
Your attention,
minus p squared
start
plus
of
q.
period 3 now.
Okay.
Please take note. It is the start of period 3.
Okay, I was expecting a longer period. Okay, so I'm just going to push through this quickly. So I'm putting a negative here. Okay, the formula above is given positive. It's given in one of the two forms. Okay, I always in the exam also put it in this form. So the P and Q is your turning points. Your turning points coordinate is P and Q. Which P did you get now? Sorry? Geography. Nice. Okay. Oh yeah. Alright, let's just get through this quickly. So y is equal to a into x. What's your P value? Remember that's your P and your Q value. So x minus 2 squared plus 3. Not so? So here we're going to substitute a point that lies on this graph. Do we have a point lying on this graph other than the turning point? Yes. Which is 4 and negative 9. Remembering this is the x and a y. Okay. So we have negative 9 is equal to a into 4 minus 2 squared plus 3. Take it over the equal sign, it becomes minus 9 minus 3 is negative 12. That's going to give you 4 minus 2 squared is 4a. Divided by 4, so I get negative 3. So what's the equation now? Y is equal to negative 3 into x minus 2 squared plus 3. And that's just squared it out from here. So y is equal to negative 3 x squared. That's going to give you negative 4 times negative 3 is positive 12x. Positive 4 minus times minus 3 is negative 12 plus 3 is negative 9. Okay? You guys understand? Okay? So out of exercise 5. I want you guys to complete exercise 5.18. Okay? But in the rest of the video I'm going to do another 2 examples. Okay, I don't want to keep you too late for your for your life science lesson. But for the sake of the video itself, I'm going to do the next two. Okay. Do you guys understand what we just did now? Yeah.
Next one.
Pleasure.
May I?
Yeah. Come inside. Okay, so as promised, I'm going to do exercise 5.18 number 2A and 2C from the using the method I've just applied. Okay. So at this point, you can pause the video if needed, and then you can attempt it on your own, and then you can just play the video thereafter. Okay. So remember, the turning point is given, so we follow the formula y is equal to a into x minus b squared plus q. So we're going to substitute the point, okay, before we go into that. Remember, your turning point's coordinate is going to be p and q. Okay, so that will be your p and your q there. So we have y is equal to a into x minus 2 squared minus 1. So in pursuit of calculating a, I'm going to substitute the point that's lying on this graph, which is 4 and 1. That's an x and a 1. So 1 is equal to a into 4 minus 2 squared minus 1. 4 minus 2 squared is 2 squared is 4. Take it over, it becomes 2. Okay. So divided by 4. So 2 divided by 4 is half. So my equation reads y is equal to half into x minus 2 squared minus 1. And then from there, it's just a matter of multiplying, okay? Which is going to be half x squared. That times 2 is negative 4, so it's negative 2x. That's going to give you 4 times half is 2 minus 1 is 1. Okay? So that is the equation of that parabola given the turning point. Alright. In 15.8, number 2C, same story. We are given the turning point. So you follow the equation y is equal to a into x minus b squared plus q. Okay. With p and q is your turning point. So we got 2 and 3. Remember again, this formula is not given in the exam. So you must remember the formula. So y is equal to a into x minus 2 squared plus 3. So you're going to substitute the point lying on this graph. So it's 3 and 1. Again, that's the x and the y value there. So 1 is equal to a into 3 minus 2 squared plus 3. You take it over, becomes negative 2. So what's my equation now reading? Y is equal to negative 2 into x minus 2 squared plus 3. Which now gives us negative 2 squared. That times 2 is negative 4. It's positive 4. No, positive 8, sorry. X. It's 4. Negative 4 is positive 8. Plus, so that's going to give you 4 times negative 8, so it's minus 1. So that's the equation of this parabola. Okay. So at this point you can Do the ratio of exercise 5.18 on page 160 and 170. Okay. See you there, every day. Good morning.